So in this video, we will cover the transformations of graphs. First, let's take a look at translation. Vertical translation is when the constant b is outside of the function fx. As you can see, b plus b is outside of fx. The translation vector would be 0b. This means all the values of y are added to a value b. And in horizontal translation, the constant b is inside of the function fx. Here, the translation vector would be minus b 0. Always remember, even though here it will be plus, the vector will be minus b. Therefore, all the values of x in the graph fx are subtracted from a constant b. Let's take a look at this example. Here we have to translate the x values by minus 2 and the y values by plus 3. Let's take a look at the x values first. Here point P is 0, 1. The x value 0 will shift to the left by minus 2. That will be around here. And the y value, which is 1, will get added to plus 3. There will be 4. The final coordinate will be minus 2, 4. And therefore, the graph will move to the left and up. And you will get a graph like this. And keep in mind the asymptote, which is y equals 0, will also move up by 3 units. Let's move on to stretching of graphs. Let's say we have a constant a that is outside of the function. So what happens here is that all the y values of fx are multiplied by the constant a. Therefore, there will be a vertical stretch. Now let's take a look at horizontal stretch. If we have the constant that is inside the function and it multiplies x, that means all the x values of the graph are multiplied by a scale factor of 1 over a. Let's understand this better using an example. The origin will remain the same because 2 times f of x, that means 2 times y value, which is 0, will be 0, and 1 over 3 times 0, which is the x value, will also remain the same. Now let's move on to this point 2, 4 on the graph y equals fx. So first let's do the constant that is outside of the function. 2 times f of 3x. So our y value, which is 4, will be multiplied by 2. That will become 8. So that will become somewhere here. And our x value, which is 2, will be multiplied by 1 over 3. That becomes 2 over 3, which will become closer to the origin. So let me move this point to the left, somewhere around here. That will be our final point, which is 2 over 3, 8. And therefore, our graph will look something like this. The graph has become compressed horizontally and stretched vertically. Let's take a look at some special cases. The first one being f(ax plus b). Now you might wonder, what should we do first? Stretch or translate? Think of this like an algebraic expression. What do you do first if we have something like ax plus b equals 0? You first bring the b to the other side, right? Therefore, similarly, you translate first. And then you divide that result minus b by a, right? Therefore, the result that you get by translation, you're going to divide it by a, or basically multiply that by 1 over a. So stretch. So first you translate and second you stretch. In the second case, we have afx plus b. Now here we do the opposite. We try to reverse engineer. So if we have x minus b over a, we are going to multiply first, right? Therefore here you similarly stretch first. And then you bring the minus b to the other side, right? Therefore it's going to be translate second. That's it for graphs and transformations. See you next time.